Well, hi, good morning. Thank you so much for joining me here in my shop. I'm going to be starting on this Montgomery Ward Airline radio. There's a story behind this radio. This is not going to be easy for me to get this guy going because of the story. I had to buy this radio in order to acquire a key part out of it, a coil. I think it's the oscillator coil. Out of it to put into an identical radio that someone had given me to repair, and that radio I had, yes, put a power drill through the same coil. So I bought this radio just to take the coil, put it in the other radio, and give the other radio working back to the owner. And I've ended up with this radio. So I've had this for a couple of years now. It's just been sitting on my shelf waiting for the day that I dare attempt to do something about this important coil, or transformer in fact, that's missing. Now I have the transformer. Here it is, or the coil. This is the one from the other radio that I managed to put a drill bit into. So this is what I have to somehow duplicate or do something anyway to accommodate. Accommodate's not the right word. Enable this radio to operate. I'm not inclined to try to perfect this radio's operation or perfect this part or anything like that. I just want this working to some degree, because right now it's completely dead. And another unfortunate thing, it's tricky to see on camera, is the glass is cracked right through the middle here. Ooh, it's even bouncy. So I believe I tried playing this radio when I got it. I bought it. It was with a claim that it was working. I'm not going to plug it in and try it now, of course, because it's missing a key part. I think I remember that it sort of worked. I think that's kind of my memory of it. This is a pretty old radio. It's loaded with some pretty old tubes. That's a 41. This is a 6A7. So they all have caps on the top. Condition of the tubes, I don't know. I can see a big filter capacitor. Looks old. It all looks old. So I want to take it out of the cabinet and examine the underside and just see what all might be involved in getting this guy to work. This could be a real challenge. It is a real challenge. There's no doubt about it. So these knobs, they just don't look right to me. These ugly white knobs, but that's what it came with. Take those off. So this radio has a transformer in it, even though it only has a few tubes. It's not a 5-tube radio as such. SC number 9. SC. Something cabinet. Small cabinet number 9. I wonder if that's what that means. Speaker staying back. Speaker's on a plug. It's a little bit unusual. Let's put this just like this here. Well, it's lots of significant rust here. It kind of looks like something got dripped on it in here. I don't know. Yeah, this one's in rough shape. Here's another coil. Similar to this one, but this is not the one. Similar sort of construction, if you like. There's a capacitor there. that? It has a metal band here, not a string. And a metal band here. Actually, it's metal all the way around, and then it's spring attached there. Different. It's actually got pins that come into these holes in the metal band to lock it in place. Wait a minute. Well, yeah, interesting. Big locking screw here. Very interesting. Okay. Now the speaker has a field coil in it, so we have to operate this with the speaker all the time. The white paper does not look original at all. It looks all replaced to me. Broken glass has been taped here. Someone has taped this. It's possible it's me. I don't remember doing that. And the speaker has a heavy hot glue repair on it. Oh my gosh, look at that. Oh man, that's a disaster. Oh boy. That's a disaster. What other sad tales can this radio tell? They're all hidden underneath there. So we're not going to run it. So if I'm going to take the speaker off. Anyway, first thing we should do with this guy probably is test the tubes. After making a little examination here. Here we go. The sad story be told. Oh, it's not so sad. Someone's done some work on this. Not me. None of this is me. There's a wire hanging out here. What the heck is that? Oh, you know what that is? That's a wire that goes to the coil. So the coil was in like this. Or transformer. So I got here one wire, only two wires? Well, maybe this is just one coil. So it would have 1, 2, 3 terminals on it. See a wire coming to this terminal. And everything else is hard to make out. Looks like a wire under the wax coming to this terminal. Yeah. We'll find out on the schematic what all's involved in that. So, great. So there's no paper capacitors. So somebody did the job on this guy, and then I came along and did a job on him too. This is cut. This is cut. Cut, 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 cut. Four wires. Sure sounds like a transformer to me. Okay. So we kind of got good news and bad news. An awful lot of black goop down here. Black goop from what? So this is the filter capacitor right here with this cut wire. See, this one's still attached. This one's attached. Looks like it's partially replaced is what it looks like. And they've left the other part attached. This is probably the negative here. Yeah, looks like it goes right onto the chassis at this point. And this will be the positive. This comes back to here. I'm not going to bother trying to figure this out looking at it, but just... Well, it doesn't look impossible. It doesn't look like a disaster other than the fact that I'm the guy who cut this coil out. Now, can this coil be repaired? We're going to take a close look at it, but I don't think so. I don't think there's any hope of repairing it. What might be possible is to utilize this as a form to wind a new coil. But these coils are very carefully wound with very special wire. Neither of which I'm going to be able to do. Let's see what we got going on. I got a 5Z4 in here. 5Z4 tube. So why don't we take a peek at the schematic at this point and find out about this tube, which just doesn't look like the rest. 5Z4. And we'll see what's going on. Okay, so here we are. Pretty sure this is the right radio. Winding instructions, alignment, tube complement. Rectifier tube 5Z4, and that's what that tube was, a 5Z4. High vacuum rectifier. It's interesting they say high vacuum. Aren't all tubes high vacuum? So pulling what today is easy to do, but back in the earlier days, very hard to do, to get a very high vacuum. So my guess is they had a typical level of vacuum in most tubes that were being built back then, and then for some tubes, because it was necessary, they pulled an extra high vacuum with extra vacuum pumping equipment, and that's why they would refer to this. So the guess here would be you need a high vacuum in a rectifier tube. For some reason I don't know, that's probably why that's there. Resonance indicator. Interesting way of putting it. So let's take a look at the schematic here, and we'll look for the coil. This is probably the coil right here. This is the antenna coil. It's probably up on top. And here's the coil I've destroyed. It's got two windings, completely separate. Got the resistance written on them, 8 ohms and 4 ohms. And the idea here is you're setting up a feedback out of this coil, which is the screen, first screen. This is going to act a little bit like a plate. And it's going to carry amplified signal in here. Some of that is going to get into this secondary side and be fed back. Oh, look how they're doing it. What are they doing there? Okay, so that's not the way it's going back. It's going back. It's going back from this line to the first grid. Yeah. So the local oscillator is driving the grid number 1, and the signal coming in from the antenna is grid number 4, I guess that would be. What's there next to it? So that's the screen grid. And after that comes, oh. Okay, so I don't quite follow this. You would think normally it would be a signal grid and then a screen grid, and then if the plate was coming soon, you have a suppressor grid. That's a suppressor grid. But 100 volts on it. It's not a suppressor, it's a screen. So the screening there, screening there. What is this? Well, I think this is interesting. So I guess this second grid 2 is used like a plate in an amplifier, I guess. 136 volts on it, 100 volts on the suppressor. Now, this guy's going to get AVC somehow back here. grid, ABC development. Oh, okay, so we've done something a little different here. The one plate on the output of the IF, that's going to give you the output here, and it's heading for the volume control elsewhere. And then it feeds down, as you might imagine. This is probably a very large resistor here. This is a very, very simple radio. Feed down and generate the AVC for the grids of the first two tubes. But this second plate here is interesting. I've never seen that connection. Kind of bypasses this. So I really don't know what this plate is doing. Okay, a little bit of just some unusual stuff. Every radio is done a little different. The engineers designing these wanted their own designs. Anything spectacular going on down here? Pilot light. Big L. Big L. I don't remember seeing a big L in there. There's that resistor that was slapped up against the side. These negative voltages coming out here. These are probably used for, so there's a grid supply. So this is how they're biasing this tube, like the output tube here. They're not using a cathode resistor. They're doing it right from the power supply with this resistor. So that's kind of interesting. And then 4, probably through a big resistor here onto that grid. That's quite different, quite a different approach. And then 3 volts. What's going on here? 3 volts negative on the cathode. .2 on the grid. Well, I don't know. Never seen that done exactly like that. Don't really know what they're up to, but they're up to something. But no cathode resistor in the output tube. 6A, 7, 78, 75, 41. Yeah, I think maybe tube testing is next, really. So let's just look at this coil again. So I got to try to imitate this. I may have drilled out only one side of this. I may have damaged only one side of this. The other side may be perfectly fine. So I may be half done from the start. How do you do the antenna? So the antenna comes in and goes through a transformer. So there's no direct connection from outside to inside here. And right onto the grid. And this little tickler. You know what I think they're doing here? I think they're using this not really as a through tube where the current is going through it, although it may be going through it. They're really using this like it's 2 tubes. One of them is just operating the oscillator. That's these 2 elements here. And then the results of the oscillator are impressed with this little wire amounting to a capacitor onto the grid with the antenna signal. That's what this looks like to me. And then I guess having the 2 of them on the same grid, you can mix them, I guess. I didn't really realize that. Or maybe I'm not getting it here. Just goes to show you every radio is different. And the subtle parts are different. Okay, back to this coil. So I don't know what to do about it yet, but we'll carry on. Let's test the tubes and get through that. Just a nice parts list here. Coils. Here's the coils. I can order one. I'll order one. Input IF, output IF. Oscillator coil assembly complete. No, mine's not complete. That's the problem. March 7th, 2015. So that's roughly when I acquired this radio. 2015, 4 years ago. This thing's been sitting for 4 years. Okay. Okay, I think we're ready to go here. We got the 5Z4. 5Z4, we'll just double check. Filament 5 volts, 06030, 06030, P070, 25, E, P1, P2, there's 2 plates. Expect the short on short test setting 1. That's it. There you go. Wow, it really dipped. Line check. A little low. This guy seems to be sucking it back. A short test. Short shows on 1 as expected. Rectifiers. Rectifier has to get up above this area here where it says rectifiers okay. Plate 1. Plate 2. This tube's fine. Out you come. Okay, that's good. Now, next tube we will pick. We'll pick this one. Here. 75. It's a number 75. Okay. Number 75. Looking over here. There it is. 75, 6.3. Signal level 1. 20L. Right there. 73001. 73001. 6,000. $37 D. No, 37F. Don't make a mistake there. $720 grid cap placed on top. Grid. Okay. Shorts. Test good. Okay, so on the GM test, should come up to 720. 720 is, roughly in there, just above the 50. Perfect. She's good. Wrong switch. Just let it cool off a touch. I figure when you're dealing with tubes this old, they really deserve some care and attention. I really couldn't tell you what the world supply is of tubes like this. 41. So this is the number 41. 41. Okay. $41, 6.3, signal level 2, 46H. 46H. 73451. 7 3 4 5 1 6,000 33 and F. Correct. 1 6.3 46 H 73451 73451 6,000. No grid cap. Oh, I gotta switch it on. Okay, any shorts in there? None showing. Now this one should test at 690. Way down here. Oh, excuse me. What are we doing? 690. Oh, it's way above. Jumping around a little bit there. It's okay. There we are, number 41. Put that back in. Okay, next tube we're going to do is a 6A7. 6A over here. Six A7, 6.3, signal level 1, 27L. 73445 73445 1600 30 C grid cap whole tube. Go there. Okay, grid cap. Power on. Okay, shorts. 6A7, 750. 750, you know, right around that number 50 there. Bingo! Good shape. Wow, okay, these are all coming out quite good. Since Ward's right on it. I have only one more tube to do. Just pop this one back in here. Okay, and then the last one. Okay, a little bit of a problem on the last one. I'll show you in a second. Here it is here. It's a, where's the number? There. 78. And the grid cap has been pulled off. The grid cap, unfortunately, has stayed here. It's going to go flying here. Jeepers. Let's try prying it. Oh boy. So I've never actually reattached a top cap to a tube. Never actually done it. Should be pretty straightforward, really. But it's, you know, gluing it back to the top. Never really faced this problem before. Let me just see if I have a replacement for this tube. Let's see, what can we do to test it? Okay, the 78's in, it's warmed up. I've got the grid connection with this clip lead. Leaks. No. So if this guy's good, he's going to show up at 1100 up about here. Oh yeah, look at that. Now, how do I know this grid thing isn't? I'm going to just do the test with the grid disconnected. Yeah, it's obvious that worked. Okay, because of the very different reading. Excellent. Good tube, in bad shape. You know, I could actually, you could potentially attach the wire in the radio right to this. So that would be the easy thing to do. Just solder the wire right to this. What does it matter? That's probably what I'll end up doing. Forsake the cap. So what to do next with this radio with no oscillator coil? Yeah, you know what? Maybe this is an opportunity to try an external oscillator. Instead of a local oscillator, try an external oscillator and inject an oscillator signal right into the mixer tube just for some fun, and see if I can't utilize equipment in my shop to make the radio work without this coil being in there. That might be some fun to try. How successful that would be, I don't know. But as usual, I would like to get this thing working as quickly as possible. And so I can make assessments on it. Wow, this is pretty fragile here. This is right out where whack. Catch it with a tool in your hands, or install it or pull it out of the radio and just break this right off here. Wow. So that's an interesting, hey, you know what? I think I will experiment with it. Should I fire it up now? What would happen if I fired it up now with no local oscillator? I don't think anything would get damaged. The radio wouldn't work. Some sounds might come out of it. How would that be helpful? Yeah, just in thinking about it, I think what I'm going to do is I'm going to try the external local oscillator trick and fool around. You know, at the very least, I'm going to learn something. Hopefully, I'll probably learn to never try that again. That's okay. So thanks. Hope you're enjoying your holiday season, and we're just waiting for a lot of freezing rain to hit here today. A big freezing rainstorm. So we'll see you tomorrow, unless I'm buried in ice.